Welcome to the deep dive. This is where we try to slice through all the information overload and really pull out the most important ideas just for you. Today, we're taking a serious look at what's become a really foundational skill in this AI era, prompt engineering.
hmm
Our source material is a illuminating peek into that O'Reilly book, Prompt Engineering for LLMs, The Art and Science of Building Large.
Right, that's a key one. And our mission really in this deep dive is to try and get past the buzzwords
Yeah.
and really understand what prompt engineering is, at its core. Where did this practice actually start? And maybe why mastering this craft, talking to these AI models, why it's so absolutely essential if you're working with large language models today.
Okay, yeah, let's unpack this. If you've been following the space at all, you know that large language models like, GPT-3 and all the ones that came after, they suddenly seem to gain this incredible flexibility.
Hmm.
And the source, it really pinpoints a key moment around 2020, I think.
Hmm.
With that paper, language models are few-shot learners.
Exactly.
Yeah.
That paper focused on GPT-3. It showed something, well, kind of counterintuitive, but incredibly powerful. Researchers found that instead of needing, massive, expensive retraining for every single new task like translation or summarizing
Right, all that stuff.
or question answering, you could actually get the model to perform these tasks remarkably well just by changing the input.
Just by modifying the prompt.
Just the prompt,
Yeah.
exactly. By carefully structuring the text you feed to the model, you could, well, the term they use is condition it
Condition it.
to produce the output you wanted for pretty much any language task. This wasn't just, generating text anymore. This was actually directing the AI's behavior through the prompt itself.
Okay, and the source makes a really crucial point here that kind of grounds everything. At their heart, these LLMs are fundamentally text completion engines.
Yes, that's the absolute foundation. They're incredible at predicting the next word based on the just colossal amounts of text they saw during training.
They're pattern machines.
They are pattern machines. They don't understand like humans do. So the principle, the thing underlying all successful prompt engineering, is realizing that when you want an LLM to act a certain way or do a specific task, you have to make your prompt look like patterns it saw during training that led to that kind of result.
So it's not just typing a question like you would in a search engine. It's about making your input actually resemble, I don't know, a document or a conversation, maybe a report,
Precisely.
whatever format leads to the right kind of completion based on its training.
Exactly right. The book uses a great analogy for they call it the Little Red Riding Hood principle.
Yeah.
The idea is you want to stay on the well-trodden path. Use document types, use interaction patterns a model is already familiar with from its training. So if you want an analysis, format your prompt like a request for analysis I might have seen, millions of times. If you want structured data, maybe JSON or YAML, make the prompt look like something that should result in that. If you stray too far off that path, inventing completely new ways to ask, it gets risky. The model might not know what to do.
That makes a lot of sense. Stay on the path. You're trying to trigger a known pathway, something it learned during training. Okay, so what about the actual content inside that prompt? The source talks about different types, right? Static and dynamic.
It does. It distinguishes between static and dynamic content. Static content is your fixed set of instructions, maybe some context or examples, kind of the boilerplate that defines the task itself.
Yep.
Dynamic content, on the other hand, is the information pulled in just for this specific request, like the user's actual query or maybe their personal preferences or even real-time data you grab from somewhere else.
Ah, okay. Like if you're setting up, say, a travel recommendation prompt, the static part might be, you are a helpful travel agent.
Right.
Specializing in Europe. And the dynamic part adds, okay, the user is currently in Paris and wants recommendations for nearby art museums.
Exactly that. And a really powerful form of that static content is using few-shot examples. This comes directly from that foundational GPT-3 paper we mentioned.
Okay, the few-shot learning.
Yeah. You actually show the model a few examples, input-output pairs, to demonstrate the kind of behavior or the format you want. It's incredibly effective, especially for teaching specific styles or, complex output structures.
But I guess you have to be careful with those examples. Doesn't the book mention some potential downsides?
Oh, absolutely. You have to be really mindful that the model doesn't accidentally pick up spurious patterns from your examples, things you didn't intend.
Like what?
We'll say all your examples happen to involve, I don't know, increasing a number by 5.
Yeah.
The model might learn, okay, the pattern is always increase numbers by 5, even when the real task has nothing to do with that.
Ah.
You're subtly influencing its pattern matching, so you need well-chosen examples.
Okay, so few-shot examples are powerful but need careful design.
Got it.
Hmm.
What about just the arrangement, the order of information within the prompt itself? Does that matter much? Oh, significantly. It matters quite a bit. The book gives this really fascinating example, asking an LLM to count the words in a long passage of text.
Which they're not great at, usually.
Yeah, only pretty hard for them, yeah.
Yeah.
But they found that asking the question, how many words are in the following passage,
Mhm.
before you actually show the passage? Before. That yielded much better results than asking the same question after the passage.
That seems totally backwards. Why would asking first be better?
Well, it tells us something maybe about how the model processes text. It seems to process it sequentially, right? And it doesn't have an easy way to kind of go back or have an internal monologue to reevaluate or look up information it just saw.
Yeah.
So the structure, the order you provide information in, it shapes how the model builds its internal state, its representation, for that completion task. Prompt assembly, getting all the needed context in, staying within the token limits, structuring it logically, that becomes a really key skill.
Wow, okay. So it's not just what you say, but how, and crucially, when you say it inside the prompt. That's fascinating. And then once the model actually starts generating in the text, how do you, I think the source says tame the output.
Yeah, tame's a good word for it. That's where things like stop sequences come in.
Sequences.
These are specific tokens, words, phrases, punctuation that you tell the model, okay, when you generate this, stop.
Ah.
Because without them, the model might just keep completing text indefinitely. It might ramble or confabulate is the term, basically make stuff up.
Right, just keep going.
Exactly. Stop sequences let you define the endpoint. Tell it, this is the end of what I want.
Okay. And the book even gets pretty technical here, right? Talking about using logprobs, the underlying probabilities. Why would a regular prompt engineer need to care about that level of detail?
Yeah, logprobs. That's where the science part of prompt engineering really kicks in, maybe.
Yeah.
Logprobs are essentially the model's confidence score for each word choice it makes. Yeah. Now, usually you're just focused on the final output text. But understanding logprobs can be super crucial for debugging a tricky prompt.
How so?
Well, if the model goes completely off the rails, right, looking at the logprobs can show you where it went wrong. Was it highly confident when it took that wrong turn, or was it just wildly uncertain at a key point? That points you towards different fixes. Maybe your prompt needs clarification. Maybe the examples are confusing. Maybe the input data is weird.
I see.
It helps you understand why the model did what it did, not just what it did.
Okay, yeah, that makes sense. A diagnostic tool, basically.
Right.
And once you have the output, evaluating its quality is obviously critical because, as the book really emphasizes, these models are probabilistic. They will make mistakes.
Right. And evaluation isn't just, reading the output and saying, yeah, it looks good, or having a gut feeling.
No.
The source outlines more structured approaches. They talk about offline evaluation. So testing extensively before you deploy something, and also online evaluation, which uses real user interactions after deployment. You look at metrics like direct user feedback, thumbs up and thumbs down, or does the output actually achieve the goal functionally? What's the acceptance rate if it's part of a workflow? You can even use other LLMs to help evaluate.
Interesting.
But you always need human judgment to ground truth it, of course.
And they propose a specific framework for this evaluation called SOMA.
Right, SOMA. It stands for Specific Questions, Ordinal Scaled Answers, and Multi-Aspect Coverage.
Okay, break that down.
So instead of asking a vague question like, was the summary any good?
Yeah,
specific questions like, did the summary identify the main point correctly? Then use an ordinal scale, like 1 to 5, not just yes, no, for measurement.
Okay, a rating.
A rating. And crucially, you cover multi-aspects. You check for accuracy separately from tone, separately from brevity, or whatever factors matter for that task.
Ah, so you get targeted feedback.
Exactly. It gives you structured, actionable feedback so you can actually go back and iterate on your prompts effectively.
Okay, so this core principle, shaping the prompt to look like training patterns, it goes beyond just generating text, even into these more complex interactions.
Oh, absolutely. A huge part of making LLMs useful in the real world today is giving them tools, right? Letting them interact with the outside world, call APIs, access databases.
Yeah.
And the book explains that this is managed by, well, you guessed it, carefully engineering the prompt.
Still the prompt.
Still the prompt. You provide the model with descriptions of the available functions or APIs, usually using some specific syntax the model's been trained on, and the model learns, based on patterns of tool use it saw in training, to decide when to call a tool and how to format that call. based on the user's request framed within the prompt.
And then the application code, the part outside the LLM, it sees that tool call output,
Hmm.
runs the actual tool, gets the result, and then feeds that result back into the conversation as part of the next prompt.
Exactly. It's still all about shaping the conversation history, which is part of the prompt for the next turn.
So even sophisticated tool use boils down to conditioning the model through that prompt structure, making the prompt look like conversations where tools get used effectively.
Precisely. And for even more complex tasks, you start moving into what they call LLM workflows.
Okay, workflows, like chaining multiple steps together.
Yes. Instead of trying to get one single LLM call to do everything, which is often fragile, you break the problem down. You create a series of tasks. Some steps might use specialized LLMs with carefully tuned prompts. Other steps might just be regular software, traditional code.
Right.
The book gives an example, I think, for like a Shopify plugin workflow.
Mm-hmm.
It might involve steps like scraping product info, then analyzing customer reviews, then generating some marketing copy ideas, and maybe finally drafting an email. Each step could be a separate module.
So instead of one giant monster prompt, you have a sequence of smaller, specialized prompts and maybe some regular code all working together.
Exactly. Or, in really advanced setups, you might even have a central LLM acting as an agent of agents.
Wow.
Yeah, its own prompt is engineered specifically to decide which specialized subagent or tool is the right one to handle the next step in the overall workflow. It becomes an orchestrator.
Okay. So let's try and tie this together. We started with that core insight from the source. LLMs are basically pattern matching text completion engines, right?
Fundamentally, yes.
And the big principle that falls out of that is that prompt engineering is this art and science of shaping your input, your prompt, to resemble the patterns the model learned in its training data. You're guiding it towards the completion you actually want.
Absolutely. And we've seen how that single idea applies pretty much across the board, from,
Yeah.
simple few-shot examples
Right.
to carefully structuring complex prompts, figuring out the order, using stop sequences, then leveraging powerful tools by describing them in the prompt, orchestrating those multi-step workflows, and even rigorously evaluating the output using frameworks like Soma. It all comes back to shaping that input.
But, okay, here's where it gets really interesting, I think. And the source hints strongly at this. The pace of change is just accelerating like crazy.
It really is.
They mention things like multimodality, models like GPT-4 that can process images as well as text, maybe by converting images into vectors and sort of mixing them in with the text vectors.
Yeah, integrating different types of data. And they also touch on new training approaches, things like knowledge distillation.
Distillation.
Yeah, where you essentially teach smaller, faster, cheaper models to mimic the output distributions, the probabilities of the much larger, more powerful ones.
So you get some of the benefit without the huge cost.
Potentially, yeah. The experts cited in the book, they're very clear. Progress isn't slowing down. If anything, it's speeding up rapidly.
Makes you wonder if, as the source kind of playfully notes, that Ray Kurzweil guy was onto something about the exponential pace of change.
Doesn't it just...
Yeah. So this brings up, I think, a really important question for you, the listener, to maybe mull over. In a world where these models are rapidly becoming multimodal, they can see now, as well as read, where training techniques are constantly evolving, and the basic capabilities are making these huge leaps in just months. How far can that foundational principle we talked about, just shaping the prompt to resemble known training data patterns, how far can that alone take us?
Right.
What happens when the models have fundamentally new kinds of patterns based on seeing images or maybe other senses down the line? What new patterns will emerge that we'll need to learn how to trigger? And how will this whole art and science of prompt engineering have to adapt, maybe fundamentally change, to keep up with models that can perceive and, well, maybe think in ways we're still just beginning to grasp? Something to consider.